Hello and good afternoon, and welcome to this video tutorial, which is a continuation on our investigation into the BGP best path selection algorithm. We've looked at weight, we've looked at local preference, locally originated via the network and redistribute command as opposed to aggregate. And now we are at step 4 in the BGP best path selection algorithm, which is the AS path, or the autonomous system path. So as a quick review, remember that the autonomous system numbers, those are the numbers that are defined by a specific autonomous system. And let's describe, or let's define real quickly, what an autonomous system is. So an autonomous system is a group or an enterprise, or it could be a company, but the autonomous system is under their administrative control. If you take a look at RFC 4271, which is the most recent RFC for BGP 4, they'll give you sort of a textbook definition, but it's where all of these systems within the autonomous system are under the control of an individual entity, right? So we could say that this is company A, and I've been having some problems with my pen here, so we'll say company A. This could be company B. This could be company C, company D, and company E. And again, if you think about it, it makes sense, right? Because each of these autonomous systems is under the control of the individual entity. So in other words, company A, let's say that company A is AT&T, is probably not in control of the administration of all of the systems in the Sprint autonomous system, right? So again, the Sprint people are in charge of what's in their autonomous system, and the AT&T people are going to be in charge of what is in their autonomous system. So how does the AS path work? Well, let's quickly drop over here to the Cisco document that we've been working off of here. And again, we're focused here on step number 4. We're going to prefer the path with the shortest AS path. Now remember, BGP isn't looking at the speed of the interfaces between the autonomous systems. It is simply looking at the sheer number of autonomous systems that reside between the source and the destination. And so that is how step number 4 comes into play. Now, very important point to touch on here, as that this is the default for BGP. So what do I mean by default? Well, number 1 was weight, number 2 was local preference, and then we got into a discussion over network statements originating the NLRI as opposed to redistribute statements. So if none of those things are changed, if you don't touch weight, if you don't manipulate local preference, and you don't do anything for step number 3 with the network statements and the aggregate and things like that, you will end up by default right here at step number 4. And so this is sort of where you end up initially before you get to 5, 6, and so forth. Because again, there's a possibility, and we're going to see that here shortly, that the AS path length could be the same. And if you remember back to the drawing that we have, which we'll touch on here as well, we've kind of pre-canned it so that it will show us a scenario where the AS path length is the same. And then at that point, it's going to prefer the path with the lowest origin type. And then it's going to prefer the path with the lowest med value. And so we'll get to these in turn. But let's focus again on the AS path, the autonomous system path. And so in the drawing that we have 100, and that goes to 300. And then over here to, I think this is 900 on the left, and then it's 400 on the right, and then 5, 6, 7 down here at the bottom. And so, and then we have a link, a special link here that runs like that. So again, it's just simply counting the number of autonomous systems between wherever I'm looking at the information. So the point of view of AS567, if I'm looking at NLRI, or prefix information being originated here in Autonomous System 100, I'm going to see an AS path for this direction, which would be 100, I'm sorry, let me do it from left to right here, which would be 900, comma, 300, comma, 100. And that's coming this direction. If I change the pen color here to try to make it a little more clear, I'm also going to pick up a path, an AS path coming that direction, which is going to be 400, comma, 300, comma, 100. Again, we read from right to left in terms of the first AS or the originating AS for the prefix, and then we go in this direction. And it may seem a little counterintuitive, but if you look at it from the left to the right, like we normally read in English, this would be the AS from which I'm learning the information, right? So this is the AS I'm peering with that I'm receiving that information from, the last AS that it goes through before it comes into my autonomous system. And then we'll do green. There's also a third path that goes this way. Now, when we look at the green path, we see that it's going to show 300. Let's make sure we get the zeros in there. 300, comma, 100. So the AS path length here is 3. Because again, if the prefix, and we'll say it's the 1.1.1.1, if that originates up here at AS 100, somewhere in this company's autonomous system before it reaches the public internet, if the red path is chosen, it's an AS path length of 3. If we go via the blue path, same thing. We have to transit 3 autonomous systems before we get to our destination. And then finally, if we go the green path, we only have to transit 2 autonomous systems, 100 and 300, and then we end up right here at 567. And so that is the AS path, and this is how the AS path is evaluated by the BGP best path selection algorithm. It's not the shortest AS path in terms of, 3,000 is shorter than 30,000. It's not the number of digits. It's the actual number of autonomous systems through which the NLRI, or the prefix information, the route, is transiting in order to get to, or from my point of view. So let's go ahead and let's take a look at that, and let's jump onto the command line here. And we'll see what we're talking about. So we'll change this back. So again, from the point of view of autonomous system 567, and let me get on to router 6 here in autonomous system 567. We'll go from user exec to privilege exec, and I'm simply going to say show IP BGP. Now let's remember that's sort of the old school way, and I will change frequently. I'll do the old school version of the commands and the new school, what I like to refer to as the new school form of the commands, which is the multi-protocol version of the command, where we say show BGP IPv4 or show BGP IPv6 or show BGP VPN v4 or VPN v6, so we can see the different address families. So we're not working with the address family specifically here. This is just IPv4, but I will move back and forth so that you can see what the different commands look like. So let's take a look at the information here, and this is the BGP. Now remember, I said show IP BGP, and I probably want to be red for this. I said show IP BGP. This is going to show me what they refer to as the lock or LOC rib, and what that is this is the BGP local routing information base, or routing information database. That's what that base stands for. It's the local BGP rib on this router, right? So on router 6. And we can take a look here. You can see that we've got some information here on 1.1.1.1. And there is a list of the AS paths through which that prefix, this NLRI, traveled in order to reach me. It went through AS, well, it originated in AS 100, and then it traveled to AS 300, and then it showed up here. right, at AS567. So my AS path length is 2. So how do we see that? Well, let's go ahead and say show IP, where are we at here? Show IP route 1.1.1.1. And if I hit enter, you can see right here that it says AS hops 2, right? And that corresponds to the number of autonomous systems through which that prefix traveled prior to reaching my autonomous system, which is AS567. And we can confirm this. If I were to say show IP route 3.3.3.3, how many AS hops does it say there? So we'll say show IP BGP, right? For 3.3.3.3, we have 1. It originated in AS300, to which AS567 is directly connected. Let's take a look at another router that's going to give us a little more output to deal with here. We'll take a look at router 3. So we'll say show IP, or let's do new school. Show BGP IPv4 unicast. And as you can see, we've got a lot more going on here. In fact, this is how we want to build, right? Start small on router 6, and router 6 only had individual paths because he's learning that information from other eBGP peers. But now we're on router 3, and if we look at where router 3 sits in the drawing, router 3, or autonomous system 300, is right here. So autonomous system 300 is peering with AS100, AS900, AS400, and AS567. So autonomous system 300 has 4 different eBGP peerings. And that's going to give us a little additional information that we're going to have to digest and work with here. But this is the information we want to see because this is the information where we're going to be able to differentiate between the autonomous system path length being chosen or being used as the deciding factor. So let's take a look at 5.5.5.5/32. Now we know this is coming from AS567, and we know it's router 5. 6.6.6.6, same thing. It comes from AS567 from router 6, as well as 7777, which comes from 567 from router 7. Now, when we take a look at these 3 prefixes, this is router 3's view. This is the local BGP rib, routing information base, right? The database on router 3, where it has the information that it takes in from the other eBGP peers, and that information's originally put into the adjacency rib in, right, which is another BGP table. And then if there's any kind of route map filtering that we're doing, it's then processed. And then there's the BGP best path algorithm runs on those received prefixes, the received NLRI, and makes a decision as to who is going to be valid, right? The asterisk is our valid and best is our greater than sign. You can see right here, valid and best. And that means that of these 3, and we'll talk about just the prefix for 5555 right now, of these 3 received prefixes, or I should say these 3 received NLRI for 5.5.5.5, we received one from router 7, from router 4, and from router 9. Because again, remember, router 3 has 4 peerings. And so all 3 of the peerings that are south of router 3 headed in the direction as to where these prefixes are originating. 3 is learning that, hey, I've got 3 different paths to get to 5.5.5, but BGP will only install the best path. The single best path is the path that is going to be installed into the rib, not the local rib, not the BGP rib, BGP loc rib. It's just the show IP route. The routing table on the router is only going to get a single BGP route because that's what the BGP best path selection algorithm is all about. Selecting the best and valid single route to install into the router's routing table. Because again, you can see here, I said show BGP IPv4 unicast. I did not say show IP route. So we are looking again at the lock rib or loc rib. Oops, sorry, not robe. We're looking at the loc rib, the BGP routing information base. And this gives me the information over here that the decision is being made on. So let's take a look. Wait. The weights. What do you think? It's a push, right? We got a tie here. So the weights are all even. The next criteria is local preference. Well, here's the local preference column. And you can see the local preference, if it doesn't show, by default it's 100, but it doesn't list for anything here. So we've got a tie with the weight, which is our number one guy, number one criteria. We've got a tie with the local preference, which is our number two criteria. And then it talks about it being locally originated. Well, it's not locally originated, right? Because we're learning it. Origin code here. It's originated, and where's the origin code? From an IGP is how it refers to it. We've introduced it into the BGP domain via the network statement, right? So again, step 3 doesn't come into play either. So now we're left with step 4, which is the shortest AS path is the winner. And let's take a look. So remember, router 3 is directly connected to, or I should say, autonomous system 3 is directly connected to autonomous system 567. So when AS300 learns about these 3 prefixes from AS567, it's going to have a single autonomous system in the AS path because it's directly connected. And take a look here. There's no coincidence that the valid and best BGP path that BGP, the BGP best path selection algorithm, has chosen here is the one with an autonomous system length of 1. And again, let's confirm this. Don't take my word for it. Let's go ahead and let's run again. Whoops, very common command. Show IP route. We'll get this back here. Show IP route for 5.5.5.5. The AS hop or AS hops 1. What about 6.6.6.6? AS hops 1. So again, when we talk about the shortest autonomous system path, and that's if all else is equal, right? You haven't changed the weight, you haven't changed the local preference, you haven't done any type of aggregation, or we're not talking about local origination with the network or the redistribute command. By default, BGP will run into right away the shortest AS path as being the criteria as to which route will be selected for the prefix in question. And here you can clearly see that in all 3 cases, 567, or I should say 567, so it's going to be router 3 is going to be the next hop for all 3 of these prefixes. Because again, we've got this directly connected autonomous system, and so there's only one AS they have to hop over. You can see they lost out, or I should say that router 3 or autonomous system 300 and router 3 will be the next hop, and it won out over these other 2 here because these have 2 autonomous systems in their AS path, and so obviously 1 is less than 2, therefore this will be the valid and best path. So now let's take a look at what happens here. I'm going to clear the screen. What happens on router 3 if I go into global config and we'll say do show IP interface brief, and I'm trying to remember the interface we were using here for the direct connection to router 7 is serial 010, and I say shut. So what I've done is I've basically shut down the direct connection into autonomous system 567. So with no direct connection, what would we expect to see when I say show IP BGP, the old school form of the command to see the BGP local routing information base? And again, these are the prefixes and the routes, the NLRI, that the BGP best path selection algorithm will evaluate in order to determine who is going to be my best path, and that, and only that path, is going to be installed into the routing table, the router's rib. All right, so now when we take a look, there is no more direct connection. So we see that the valid and best for 5.5.5.5 is now toward router 4. Because the autonomous system path length here, as you can clearly see, we have a push. Because the AS path length for both of these, for 5555, 6666, and 777, it's all 2. I'll make sure I get the right ones here. So you can see they're all 2. And so what BGP will have to do now is it will have to continue down the best path algorithm selection choices and evaluate each one of those criteria in turn until it gets to the criteria that will be the deciding factor. So, and we won't walk through that right now. We're going to, again, stick focused on AS path. So let's do a no shut on that interface. So if I were to go ahead and say, we'll go from privilege exec to global config serial 010 and say no shut. Let me save that off while we're doing that. All right, how about a new school, right? The multi-protocol show BGP IPv4 unicast. And this is going to show me the IPv4 BGP local rib. You can see that the neighbor came up. Did we get the information? We did. We got it very quickly there. But again, take a look. BGP auto-magically took a look and said, my new valid and my new best, upon receiving the update, right, the BGP update message in which you will find the AS path information, and it quickly reruns the best path selection algorithm and comes back and tells you that the new valid and best path and the best path that I am going to install into the router's rib, the router's routing information base, is going to be the one with the next hop of 209.165.37.7. So let's see, is that what happened? Did it in fact show IP route? And we can see for those 3 BGP routes, sorry about that, went past those. For those 3 BGP routes, who is the next hop? Exactly. The next hop is router 7, who sits in AS 567. Now you'll notice that even though those other paths are valid, right? If we go back up here just a little bit here, you can see that these paths are valid. They are legitimate paths. And to be legitimate, it means that BGP has received the route and has information that, and recursive isn't the right word, that can resolve those routes. So these are legitimate routes, right? They're valid routes. However, they are not the best route to get there, because the BGP best path selection algorithm is saying, no, we are at step number 4. I have evaluated step 1 for weight, step 2 for local pref, step 3 for if there was any aggregation or if we had origination with the network or the redistribute command. And we are on step number 4 right now, where I am simply looking to say which one of these routes has the shortest AS path length. And or I shouldn't say which one of the routes, which one of the NLRI, right, or for these prefixes has the shortest AS path length. And that is currently going to be the route through router 7, which is AS 567, because it's a single autonomous system path. Now, I just commented a second ago, and I will definitely zoom in on this in post-production, but I commented a second ago that the AS path, remember, that is a well-known mandatory field. Now, it's well-known mandatory, and well-known means that all BGP implementations know about AS path. So, in other words, HP's implementation of BGP understands what AS path is and what it does. Juniper's, same thing. Arista, same thing. So that's the well-known aspect. Mandatory means that you have to have the AS path as part of the update messages that accompany the prefix information or your network layer reachability information. And that's going to show up in the update message. So here is it's from this topology, but not from router 3, because I wanted to have it pre-canned and ready to go here. So take a look, BGP update message. Well, let's take a look. So here's the marker field. The length is 66. What type is it? Well, it's an update message. Now we're going to look at the network layer reachability information. You can see it was just for that prefix there, for that NLRI. So we get an update message for this network layer reachability information. And this gives us a clear definition of what the NLRI is, or what NLRI stands for in the BGP context. NLRI stands for simply nothing more than the prefix, which you see here, 11.11.11.11, and the length. So the combination of those two things make up the network layer reachability information. So we've seen that, but now what are we interested in? We're interested in the path attributes. So BGP, again, remember we said we've got some well-known mandatory attributes. And before we expand this, it's going to be origin, it's going to be the AS path, and then what's the third one? Think about it for a second. Next hop. You've got it. So we've got origin, AS path, next hop, and then we've got some others here which are not well-known mandatory. So origin is mandatory, AS path is mandatory, next hop mandatory. So we're interested in AS path. So I'm going to expand AS path out, and you can see right here we've got some flags. It says well-known, it's transitive, and transitive here meaning that it's going to go between autonomous systems. And it is a well-known mandatory. Again, origin, well-known mandatory. Next hop, well-known mandatory. But let's focus on AS path right here. You can see the type code for AS path, it's type code 2. Origin is 1, next hop is 3. So AS path sits between origin and next hop in the update message in the field that has the path attributes. So the length here was 10 bytes, and here it is, AS path, 300, 100. So we know right now that in Autonomous System 100, that's where the NLRI originated. And it had to go through originated in 100 through 300 to reach its destination, right? Or this update message to reach its destination. So now let's talk about the AS path segment. So here's the AS path segment. And you can see right here, path segment length, 2 ASs. And so there's 3 values, right? There's 3 value fields that come along with autonomous system path information. And that is the path segment type. And you can see here it's AS_sequence. And what that means is that we have an ordered list of autonomous system numbers. I'm going to show you what AS set is, which is the other value. And AS set comes into play when we're talking about aggregation. And in the context of BGP, aggregation is simply BGP's way to say summarization, right? So we talk about OSPF and eIGRP, that is summarization. When you're taking multiple prefixes and summarizing them into a single prefix, we say summarization. With BGP, you say aggregation or aggregate, right? And that's where we'll get that second value of the path segment type, AS set. And again, and then you have the path segment value. And the value is just nothing more than a list of the autonomous systems through which and from which this NLRI had to travel and was originated from. So again, originated in AS100, traveled through Autonomous System 300 to reach me. And again, when I say me, I'm talking about this router here, and this was between router 7 and router 6, so Autonomous System 5, 6, 7. And so this is where that AS path information, right, the well-known mandatory BGP attribute, path attribute of AS path, this is how that information is communicated. It's communicated in update messages. The AS path information must be there with NLRI because AS path is BGP's loop prevention mechanism. And there is, when we talk about the loop prevention mechanism aspect, it's mutually exclusive. And what that means is, when you talk about loop prevention and the AS path, and we talk about the BGP best path selection algorithm using the AS path, they are absolutely, completely, 100% separate. So, and you're going to see that in this next command here, where we ignore the AS path as part of the BGP best path selection. So we can ignore the AS path as part of the best path selection. Where we can't ignore the AS path is in BGP's loop prevention mechanism. And so let's take a step back here and let's go to the drawing. And so what I'm saying when we say the loop prevention mechanism for the AS path is that if I've got a prefix that originates from AS567, it's going to go this direction. It's going to go, the advertisements are going to go the update messages. BGP update messages would get sent out. As soon as I originate it, let's say we use the network command for 5.5.5.5, the loopback address here for router 5. A BGP update goes this direction via router 7, or I should say via router 7 up here to AS300. We'll have a BGP update message go this direction to AS400 and another one go here. So then the update when it gets here is also then going to jump to here. One will be sent this way, but then AS300 would send it around this way. And ultimately it's going to end up back here, and router 3 is going to send it back down that way as well. And what's going to happen is AS567 is going to receive a BGP update message for the NLRI 5.5.5.5/32 that originated in AS567. And again, we're talking about loop prevention here, not the best path selection algorithm, because again, they're different concepts. They use the same value, the AS path, but they use it for two very different things. So when AS567 receives the update in from 400 and receives the update in from 300, and again, it would come around this way as well, and 900, it's going to look at those updates, and remember that packet, the Wireshark dump that we just saw. It's going to see the originating AS is 567. In fact, let's go ahead and walk this out. So the first one it would, or I shouldn't say the first, but one of the updates that we'll see, out of the 3 BGP updates it's going to get, one will say 567, 400, 300, 900, which is the one that went that way. In fact, here, let me clear the screen here. Let's try to keep this consistent. We'll do some coloring. So one update is going to go this direction, 300 down this way, and come back in. Another update is going to go this way, from 5 to 4 to 3 to 9 and back in. And then the third update is going to go from 5 to 9 to 3 to 4 back in, and then from 5 to 9 to 3 to 7 back in. And we should have, is that right? I may be missing one here. Yeah, the green, I think, is going to have another one that would go this direction. But in all cases, right, in all of those scenarios where it loops around the interdomain topology that we have here between the autonomous systems, in every instance where the update makes its way back to 567, Autonomous System 567 is going to look at that update, and it's going to say, that is a bogus update. We possibly have a loop here because my AS is in the autonomous system path. And what that means is, if I'm seeing a BGP update message that has my autonomous system in the autonomous system path, it means that that NLRI has passed through or originated from my autonomous system. And therefore, I'm going to drop or reject that update, because if I were to accept that update, then I would pass it along, and we've got a routing loop, right? And in this topology that we have here, you would definitely end up with a routing loop, as you can see from the rainbow of updates that roll around this interdomain topology. So Again, the key point to remember here is that the AS path serves a number of functions. First and foremost, it is BGP's loop prevention mechanism. Secondly, it is the fourth selection criteria used by the BGP best path selection algorithm. Now, the reason I broke away there to talk about that for a second is because we're going to take a look at this option right here, which is the notes, right? Because remember, we're going to talk about each of these notes in turn. So step 4, we should have step 4 down cold, right? Prefer the path with the shortest AS path. Very simple. The path that has transited or originated and then transited through the fewest autonomous systems is the path that will be selected as the best path by BGP. And this is, again, the default if none of the first 3 had been changed. Now we get down to this option in the notes section that says this step is skipped if you have configured BGP best path AS path ignore. Now, a quick note on this. This is not saying that if you set this, BGP is going to automagically no longer use the AS path as its loop prevention mechanism. It is going to use it, and it's always going to use it by default. And we're not talking about AS override or allow AS in here. We're basically saying that they're, again, mutually exclusive concepts. BGP's loop prevention mechanism using AS path, that's one side of the equation, right? A totally, completely different equation is what we're talking about here, which is BGP's best path selection algorithm. So when I set this command, what I am saying is I am not going to use step 4 as a selection criteria. I'm going to skip the AS path as being evaluated, and we're going to go down and jump to 5. So we would go from step 3 to step 5. And again, that is all that command does. That command does not say, I'm now going to be accepting BGP updates that come in with my AS and the AS path. That is not what that is saying. What that is saying is I don't want to use the AS path as one of the criteria in BGP to select the best path out of the paths that I may be receiving, right? So let's go ahead and set this and see, does it do what we say it's going to do? And it's actually kind of interesting here, because what we're going to see is we're going to see that not only is this a command that can skip the AS path as being evaluated, but we'll do the old school show IP BGP to take a look at that BGP local rib or loc rib. And so we're interested here in 5, 6, and 7 again, because again, these guys, the valid and best is going, or has been selected based off the shortest AS path length of 1. Let's change that up. We'll go into global config from privilege exec. We'll say router BGP 300. And we're quickly going to go ahead and type in BGP. I'll do a question mark. You can see there's the best path option right here. So I'm going to change the default best path selection. I'm going to say BGP best path. I'm going to do a question mark, and we're going to expect to see AS path. And what do we notice immediately? It's not there, right? So I'm on 15.3 code, and it's not there. Let me drop back here, router 5. And again, we're not going to do this on router 5, but we're going to take a look, router BGP 567, and I'm going to say BGP best path question mark. And it's not on the, and this is 12.4 code. You can see we've got the code versions here. They're very tiny, but it's 12.4 code. So 15.3 code, the option's not there. 12.4 code, the option's not there. I'm going to come all the way over here to a very, very old 26, I think it's a 2611, running 12.4.16 code. We go into global config, router, BGP 1, BGP, best path selection, and it's not here either. So now this may lead you to believe that the iOSs that we're running don't support the option, and oops, sorry, let me jump back here. they don't support the option for BGP best path, AS path, ignore. But, as is often the case with Cisco, lots of commands are hidden or don't show up when we use the context-sensitive help. So if I jump back to the command line, if I say AS path, ignore and hit enter, take a look at that. Did we get an error message there? No, we didn't get an error message. But had I tried to use that context-sensitive help, look, it's telling me unrecognized command. It's also telling me unrecognized, or I shouldn't say unrecognized, but it's not that it's not there when we do that. It certainly isn't there, right? So, but when I simply type the command in, BGP best path, AS path, ignore, it works. And let's see, is that the same on the 12 code? BGP best path, AS path, ignore. Look at, I can't complete the command. If I did a question mark here, same thing, it's not there. But take a look at that. And I'm going to change that back right now. I don't want that to mess with other things that we're doing. So I took it off. But again, it works on the 12 code and the 15 code. So it's a hidden command. But this is the command that tells BGP, I don't care about the AS path length in terms of me selecting the best path. So let's see. Does that work? Do show run, let's say section BGP. Let's make sure it's in there. Did it actually take, is it in there? And there it is. BGP best path, AS path, ignore. It is a legitimate command, hidden, and it's actually showing up in my config. And now when I say do show BGP IPv4 unicast, the new school or multi-protocol BGP way to access our information, and we can see that we still see 567 as the best path. But let's go ahead and do a do clear IP BGP star. We're going to force 3 to reevaluate everything. We're tearing everything down. And again, because I don't want to wait for BGP to have to reevaluate things. So we go ahead and say do show IP BGP. All right, you can see we don't have any best paths selected yet, but it's learning all the information. It's running the algorithm to make the determination. We're going to give it a few seconds here. And it shouldn't be 567, or I should say it shouldn't be the next hop of 37.7 over to router 7 that gets selected. It will probably be either 4 or 9. And let's take a look here. There we go. We've reset the information, right? Or there are BGP peerings, which means the BGP best path selection algorithm is going to run anew and take a look at what we've got. Is this the valid and best path? No. What is now? It is now the path that's going to take the next hop over to router 4 autonomous system 400 and take a look at that. With an AS path length of 2, it is selected as the best path over the path that we know we are directly connected to the autonomous system where this NLRI is originating. But BGP is saying, hey, you told me to ignore step 4, to not look at the AS path as part of my best path selection algorithm. Therefore, I have moved on. I've gone to step 5, maybe step 6, maybe step 7, and on and on and on. And that is what the BGP best path, AS path, ignore can do for you. And you're probably wondering, in terms of use case, why would somebody do that? When would that be something you would want to do? And if you think about it in this context, looking at the drawing here, we were saying that that was going to be the best path. But what if this is a 56K fractional T1 backup length, and this is a 10 gig Metro E, and this is a 10 gig Metro E? Which way would you like to go? And so this may be one way to do that, because remember we said that BGP, does BGP, like eIGRP and OSPF, does it look at either the cumulative, or I shouldn't say the cumulative, does it look at either the interface bandwidth or the speed of the links? It doesn't. Nowhere in here does it say fastest link between autonomous systems. Doesn't exist, right? So if we know as the administrator that, hey, from AS300 to 400, we've got two 10 gig links in here to get to us, if we're saying we're AS567, or from AS567's point of view, we've got two 10 gig links to get to the information from AS300, and then a 56K backup link. How are we going to go? Maybe at that point you want to skip the 56K link. So that is just one of many options, right? Or one of many use cases that you could run into where you want to skip that step 4 right here. Prefer the path with the shortest prefer the path with the shortest AS path length. So now let's talk about these other two notes here. So this one here says an AS set counts as one. Well, remember I talked about AS sequence. An AS sequence is an ordered list of autonomous system paths that show up in the update message. An AS set is something that we see when we're using aggregation or summarization with BGP. And what this means is the AS set counts as one no matter how many ASs are in the set. Okay, so with that in mind, right, an AS set is different than an AS sequence. Remember, we talked about the AS path information that comes through with the update message. And the path segment type is either an AS set or an AS sequence. We've seen sequences all throughout. Now I'm going to show you an example of an AS set. And remember, the set is an unordered representation of the autonomous system numbers when we're using aggregation. And so here's what I've done to get this set up. If we take a look at the drawing here, all I've done basically is over here on AS900, I think it's 10.10.2 and .3, and there's 2/24s, 2.0 and 3.0/24. And over here on AS400, I did .0.0/24, still 10.10, and .1.0/24, so 24. Now, these are being advertised here to AS300, right? And I've already set this up. So that's already been set up. So now we're going to take a look at AS300, router 3, and let's see how router 3 perceives those 4 routes. And obviously, router 3, taking a look at that information that he's receiving, has the option, right, and the capability to summarize it. So here we are on router 3, and let's go from user exec to privilege exec and say show IP BGP and include 10.10. Let's push this up a little bit. So you can see router 3 is getting all 4 of those routes. And so what we're going to do now on router 3 is we're going to use an aggregate. And this is how we can force the creation of an AS set. We're going to use that. There's actually an option with the command where we say we want to preserve the AS path information. But unfortunately, it's not going to be ordered, and you're going to see why here in a second. So let's go from privilege exec into global config, if I can get into global config here, router BGP 300, address family IPv4 unicast, and we're simply going to say aggregate address. It would be 10.10.0.0, and that 10.10.0.0 with a slash, what is that, 22/22 mask there is going to allow us to create a summary of these 4 networks right there. And you can see 2 of them originate from which AS? AS900. And then 2 of them originate from AS400. And so herein lies the problem, is when I hit, oh, actually get our option on here. So the option we want to generate AS set path information. And you can see here there's also another option, confed set, which is in the note below the set that we're working with. So I say aggregate address 10.10.0.0, 255, 255, 252.0 AS set. So now let's go ahead and say do show IP BGP and include 10.10. Whoops. Include 10.10. And what do we see? Well, there it is right there. We have the aggregate. Right? Here is our summary. It is valid and best. And you can see the local preference and the weight. And look at this new construct that we have down here. We've got a brace, curly brace, 400, 900, and then another curly brace. But what this doesn't tell me is this is unordered, right? So that aggregate right there, which one did it come through first? Well, it's impossible because I'm aggregating routes from two different autonomous systems. And we see the same problem with the aggregate. If I go all the way to the top of our interdomain setup here to router 1, and if I were to say show IP BGP include 10.10 and hit enter, you can see with the aggregate, again, we have the same problem with the summary here, where we did this BGP aggregation for 10.10.00/22. This is my AS path set. It's not a sequence because it's not ordered. Because you can see here we've got these two autonomous systems grouped together. So there's no way for me to say, oh, it's 300, 400, 900, or is it 300, 900, 400? So it drops it into braces, and that is the representation, and that should be, that's an underscore there, I didn't want the dash, for an AS set, an unnumbered representation. And so what the note is saying is that irrespective of however many autonomous systems appear in here, whether it's 2 or 40 or 100, that will be treated as one AS. And let's see if that holds. So let's go here, and then we already know the command, and the command is going to be show IP route for 10.10.0.0, and take a look at the AS hops 2, not 3, right? How many ASs are shown here? We see 3 ASs here. But remember, let's go back real quick here and refer to the note. An AS set counts as 1 no matter how many ASs are in the set. And so how many ASs are in the AS set here that we set up with our aggregate command, aggregate address command? 2. So what I normally would say is, oh, 300 and then 400 and then 900. So we have 3 ASs, but we don't, because this is an AS set, not an AS sequence. And so no matter how many autonomous systems are in that AS set, currently right now it's 400, 900, but if there were 50 autonomous systems listed in there, it's only going to count as a single autonomous system hop, right? All right, well, hopefully that clears up the AS set counts as 1. All right, so we talked about the AS set, we talked about the AS sequence, and it's the same principle here. So when we're dealing with confederations, right, in terms of trying to scale eBGP, when we talk about confederations, it's the same thing. The AS confed sequence, right, or the confederations through which the updates are traveling, or the AS confed set, again, an unordered representation of the confederations, are not included in the AS path link. So be aware of those items. An AS set counts as 1 AS path. Even if it went through 80 ASs to get to you, it counts as 1 AS path if you're using AS_set. And the AS confed sequence, I don't have any confederations set up here. We may come back to this later because there are some other choices further down that talk about confederations, but nothing set up right now. All right, so that is going to conclude this video on BGP best path selection algorithm using the 4th criteria as the selection criteria, which is preferring the path with the shortest AS path. Remember, this is different than the AS path as the loop prevention mechanism, and it does not get turned off when we enable BGP best path, AS path, ignore. All right. Thanks for watching, and have a great weekend.